Okay, let me get started here. Welcome, y'all. Afternoon. I'm just going to remind you that we have infrared headsets in the back, should you not hear what I'm saying. So you know that. Yes, welcome to this session here. How to choose the correct branch device, as it says, or router, as it should be. Also, could be, because we're talking about routers here. Hope you understand that, so you're not in a switching session here. So my name is Stefan Manson, and I'm going to take you through this session, 60 minutes of a ton of content here. And they asked me how long do you need for presenting this? I said about 8 hours. But we'll see how much we can do in 60 minutes. So let's get on it. You have this, you can always join the discussion. I will do my best to monitor it as much as I can. So it might take a couple of hours or days, who knows, but I will try to get to all your questions on that alias or that team space. So go in there and post your question that you couldn't ask here. Okay, so what we're going to do now, this is a session about when you choose a new brand CPE, and there are stuff that we might want to look at here. So we're going to look at, for example, some of the less obvious questions as well, but some of the obvious questions are about when you choose a brand CPE, how do you interpret performance data? Once you've decided that you want a new CPE, you go out there and do shopping, you start reading about the performance data. Can you really trust that? Do you know what you're looking at? Do you know how it's tested? Because it's never ever an apples to apples comparison between vendors. Don't think it is. So how can you trust that? I'm going to show you a couple of things that you should be aware of, on how data can get skewed, either intentionally or not intentionally, when it comes to performance data. We're going to look at also, I'm not just going to push new routers down your throat here. You might have routers that just do just fine. So we're going to look at how do you monitor the CPEs you have today? How do you monitor those and find out if I need a refresh or not? Maybe I don't need a refresh right now. Maybe I need a refresh like years ago, because my router is really sweating it out. The way you look at that is not very obvious all the time, how you do that. So we're going to go through that part. We're going to look at the memory part, the core part, how you really go down and see, is my memory out of space? Are my cores too hardly used? Those kind of things. And when you transition into a new platform, what do you have to think about there? For the new 8Ks, for example, this is, of course, since it's branch routers, we're talking about how to transition from ISR G2s, G1s, 4Ks into the 8K platforms. I'm going to try to guide you as best as I can. What do you think about? And of course, the 8Ks are using DNA licensing, and there's a lot of myths and misconceptions about DNA licensing. So we're going to go through that in some detail here to see if we can try to debunk those myths. Am I getting stuck in a subscription? Is this super complicated? For the most part, it's not really. Just as soon as you understand it, you'll get the grip. So we're going to go through that in one step after another. But let's start with who I am. So I'm a guy who's been doing routing since 200 years back, since the dinosaurs. Really, over 30 years. I lived a pretty sad life in that sense. Been doing this forever, and I started out with in the IGS days, and I still hold some of these routers as the best routers we ever made. The 2500s, probably the best router we ever made. How many agree with me here? Yay! Cool. I have a new unused 2500 in my office at home with 914 on it. My wife finds it very odd that I don't want to take it off.
We just shut one down with 18 years uptime.
There you go. 18 years uptime. They're not unusual for those tanks. So, and I'm the founder of part of the team that took out to develop the G2s. And I take great pride in being the co-founder of the 4Ks. We were a few of us that came up with the 4Ks and how we could go from G2 into a multi-core platform that could be more modern. And we finally did it by basically taking an ASR1K and making a cheaper copy out of it. And it worked out pretty well, didn't it? So I know those platforms inside out, and I take any criticism very personally, just you know. So let's start. Basics, some of the basics. I'm not going to read all these, don't worry about it. But there are things you might want to ask yourself, the non-so-obvious. Do I really need all that bandwidth that they try to push on me? Do I need to have that 1 gig link? I had a customer recently that had went for a 1 gig link, and it turned out that they were using 20 megs. They would have done fine with a slower link. How are my features and my functions really impacting my router? How are my services I want, are they impacting my performance? Or are they just impacting memory, DRAM, and not performance? Or are they impacting both? And in that case, what type of memory are they impacting? When will that router crash because it's out of memory? How do I know? Those are things we could look at as well. And as I said, is it time for a refresh? My 4Ks, my routers I have today, how are they doing? Are they sweating? Or are they just idling? Because if you look at things, it's not so obvious sometimes. You may look at the wrong part of the router when you say, okay, this is fine. Or it's way overloaded, but you're looking at the wrong part of the router. So we're gonna make sure we look at the right part. And then once you've done that, you need to look at for a new router, and then it comes into, how do I know what performance data I should be looking for between different vendors? Because it's never apples to apples. It isn't. And there are tons of gaps and traps and pitfalls you can do here when you're trying to do this. And vendors are trying to do all they can to make the performance look good, of course. So we're going to look at a couple of things. First of all, why we always use the term aggregate in Cisco. If I had $1 for each time I get that question, then I wouldn't be standing here, I'll tell you that. Very, very common question. So why don't we use bidirectional instead? You said aggregate, is that the same as bidirectional? We have to look at what is bidirectional. What is it? 3.8 gig, is that 3.8 gig bidirectional? 1.9 plus 1.9? Some of you say yes, that is. But someone would say, this is bidirectional, 3.8 in one direction. That's 3.8 bidirectional, isn't it? It depends on what school you went to. So it's really, really not really exact. So that's why we use aggregate. And with that also comes the fact that a lot of things say, okay, if I see this number from Cisco, I should cut it in half because it's bidirectional. So there's never that performance. Nothing can be more wrong when it comes to our type of measuring. Nothing can be more wrong. Aggregate that we measure is the forwarding engine of the router. And the forwarding engine of the router is forwarding packet. It has absolutely no clue where the packet is coming from or where it's going to because it's isolated between the packet scheduler and the interface scheduler, and you can't see anyone where your packets are sent. It gets a packet, it does what it has to do, send it on to the scheduler, to the interface scheduler, and be done with it. So we never know. It could be 90-10, 50-50, 40-60, 100-0, anything between that. And you have to bear in mind also that you need to look at your own traffic patterns to see how that will relate to the router's performance. Are you doing download traffic, very cloud-based traffic? Are you doing site-to-site traffic? That will impact how much you will really get out of that number you see from Cisco because of this. But we always measure aggregate because the router's forwarding engine cannot see where it's going or coming from. And then we have Ceph. You see Ceph a lot from us. What is Ceph? Ceph is Cisco Express Forwarding, and that means that we have an efficient way of forwarding packets. And in the sense that packet comes in, only the header is taken up into the memory cache. The rest of the payload is left down in a different cache while the header is being handled. The forwarding part is doing what it has to do with the header. When it's done, sending it back to the memory cache, who's putting it back into the header again, bolting it onto the packet, and off goes the packet, switched through with line rate. Why am I telling you this then? Well, this is how Ceph works, but it will impact performance numbers. For example, if we have this router here, a 4461, I took that because it's a really good example of this. SD-WAN, IQDF, pretty advanced, heavy services. One test report says 246 megs. The next one you see says 1.4 gigs. And a third one says 5 gigs. What the heck is going on here? You confused yet? I would. It's all to do with Ceph. Fact is this, if you look at what's behind those numbers, you look at different packet sizes. The smallest packet size we measure, we got 246 megs. The mid-size and the mixed packet size, averaging 362 bytes, got 1.4 gigs. And the highest packet size, max packet size, got 5 gigs. And if you look at the ratio between them, 362 bytes is about 5.5 times the size of 64 bytes. And look at the data. It's 5.5 times faster than the 246 megs. 1400 is 3.5 roughly times bigger than IMIX 362. And the data is, what do you know, 3.5 times higher. Because the bits don't count in the payload. Only the actual routing counts. That's why you get those numbers. We switch through the trailing bits with the line rate. But since it's counting bits, you get this kind of data. What you should look at in this case, if you want to be sure about it, it's the packets per second. That is the true routing capacity of the router. Look at this, 450 megs, 450K, roughly, packets per second, in any case, because it took the same time through that header, through the routing process, every cycle it did it. So if you want the real performance data of a router, you should always go packets per second, if you can find it. That's the way you can really compare the routing capacity without having to deal with how many trailing bits you have on the different packet sizes. Packets per second is the true routing number. SPs always use that. They hate megabits per second or gigabits per second because that's for amateurs, they say. Well, we like megabit per second, but it's easy to understand and easy to compare. But bear in mind, though, that the real routing capacity is how long will it take the router to route one cycle, depending on the services it has to do. It's the same for each packet, regardless if it's 1400 bytes or the 64 bytes. Most of the time it is. Another thing is traffic patterns. You might see two different types of performance numbers for the same router and seemingly the same test case. IP routing, IMX, 3.8 gigs. Another case is saying IP routing, IMX, 2 gigs. What the heck? Going on? Well, it was measured differently. If you look at the first one, this is technical throughput. We're measuring that to show you the technical capacity of the router. And this is taking one test on each side, shooting packet through the routers. That means you have 2 times interfaces here, 2 times interfaces going out, 1 plus 1 gig going in, 1 plus 1 gig going out, 4 gigs. But what if we want to test a cloud-based service then? Now everything is cloudified. We're testing that instead. When you're testing cloud services, you're sending a GET, and the server will try to pump as much as it can to you. Now you have only one stream coming down. Nothing is coming up from the other side. Mean that you get half the throughput. But the router was still routing at line rate here. But it seems odd when you see it. But because you have one unidirectional only loading the router. So be aware of that part. Can we skew data then? Well, we can, and some do. So how do you twist the truth of performance data? You can do that pretty easily if you want to. I have an old G2 here because we haven't done it since the G2 days, but it shows very clearly what you can do to twist the data. For those who remember the G2s, how many have G2s here? Quite a bit, good. The G2s, the 1941, roughly 35 megs of data. That was how we said it was recommended to. The top series, about 400 megs. Would you then believe me if you take that router and try to state that this router can actually do 2.8 gigs? Would you believe me? I don't think so. And the 3945E can do 8 gigs. Would you believe me? Well, I can tell you it is true. They can do it if you want to. You just have to do the test case in the right way. You say no services whatsoever, same IP destination all the time, a fixed size of maximum frame size through the router, and you get this. Because basically what it's doing now is basically switching traffic. But will this ever work? Not just no. Hell no, it won't. It will never work outside a lab. Pardon?
It doesn't have a 10 gigabit interface.
No, we had to really get creative to get it to do 8 gigs, I tell you that. We have to load it up with the switch modules and try to use the ports on the service modules internally. And all we took as many of those NIM as we could and tried to get traffic into it. But the plus is there because we couldn't get more traffic into it anymore. But you know what? We had a competitor that did that. And we said, it was so unusual and high. I said, can they really be that fast? So we actually did it, but many others did. We took the competitors and tested it, and it did the same as our router. So how did it get to those fantastic numbers? And we come up with this, and oh, that's what it did. And then we tried out our own routers and got this. There you go. It can do. So the lesson here is basically if you see something that is unusually high, that looks almost too high to be good, to be true, it normally isn't true either. Just bear in mind that you see those numbers. Because we will measure those competitors' router with the same IMIX as we do, you get exactly the same performance. Okay, so enough of that. That was the how do you read performance data. Some of it, what I like to say here is basically be critical. Be critical when you read it, and I'm always super critical because I've been doing testing when I was a TME for so long. Make sure you know what's behind the numbers. Make sure what kind of services they have on so you know what you're looking at. Okay? It's very important. Enough of that now. Let's go into if you really need to upgrade. Most of you are here probably because you want to choose a new brand CPE. Question is, do you need to? Or have you been needing to do that for years? So let's look under the hood on the router and see if we can figure out a way to find out if you do that. And I have used 4Ks here because I think those are the most prevalent ones and the most common ones out there installed. So you want to monitor a CPU resources, and you do a show memory CPU. It shows 3%. Bear in mind that what you do here, you are using iOS, and iOS lives on the control plane. And iOS only looks at the control plane itself. So when you do a show process CPU in a router, you only look at the control plane of iOS. That router can be sweating its butt off, and it'll still be at 3% CPU rate. You have to look at it a little bit differently. You can also do this. This is a sorted command where you see all your cores on this one, and you can see that some of the cores are labeled 7%, that's the data plane core, but one is at hundreds. Oh my God, this is 100% when it would crash. Don't worry, the last core is always on a hot spin. depending on which iOS it is, it can be high like 85, 90, or in some areas this is 100. But this is a looking for work core that's always spinning because it's an IO core. It's always ready to take a packet in. So it's fully normal. Don't worry about it. Don't be alarmed. One core will be high. Same goes there for you see here, the workload on here. It's also the same, looking for work. You have to look at the other cores, how they are feeling. And it also comes to a point where you say, okay, how do I look at the data plane cores? Well, in iOS, that's nothing that you can do by just saying a show process CPU or anything. You will have to tell iOS to go in and look at the microcode that runs the data plane cores. And the magic command for doing that is the platform hardware QFP. Platform hardware QFP always take you to the data plane core. And now you can see some really interesting stuff. Let's say you think you want to upgrade to Boost. You have a 4K. You say, oh, would it help if I buy an additional Boost license to my router? Will I get more throughput then? Well, you might. Very likely you will, but you might not. So how do you know? You run this core, and you can look at the summary down below. And this is my lab router, so it says 1%. That's probably more than that. But this is how loaded up your data plane really is. And if you're not getting the throughput, if you think it's maxed out at whatever it might be, 100 meg or 300 meg or something, and you see a really low number on this one, yes, Boost will probably do the trick for you. If this is already at 75, 80% load, then don't bother buying it. Then you need a new platform instead. And the same goes for what is it? Oh yeah, sorry. So yeah, those are good. Those are good. And this is looking at just the data plane. Okay. Another one is good to look at as well. This is this command here. Looks at all the cores and how each core is loaded. You see the cores here. This is our platform with Boost license. So we have all the cores we can now, and it's the data plane, or packet process as it's called. PP, you can see up here. So you can see that 4 of the cores, or actually 5 of the cores, are doing PP work, packet processing work. One core is not doing packet processing. It says 0 up there. It's doing something because there's numbers on it. But you also can see that there is no idling. There is nothing left. It's actually completely fully loaded. This is the IO core. You can see RX and TX. It's at 43 and 30%. It's handling data in, taking data out, it's taking packet from the line, sending it to the forwarding processor, and getting packet and sending it out. That's fine, but you also see that why is it 0? Because in a 4331 or 4330, that IO core is also doing crypto. And in this case, crypto maxed it out completely. This is a test we did. So crypto maxed it out. And this means when this is maxed out and the IO core is maxed out and can't do anymore, no more packets. Because I have no more resources to take in packets. That means that you might get now a router that doesn't perform to what you're supposed to be performing, because crypto, you have enough crypto so that it actually maxes it out. And when you get this, if you have this without changing your traffic pattern and without doing some really good big change to that, then you will have to upgrade to a bigger router. Otherwise, you won't get away from it. Okay. So those are some good tips of how you can look at the cores. And that platform hardware QFP is really good to have to look at what's going on in the data plane, because it's the data plane that really is doing the work for you. In our router, and this goes for the 8Ks as well. The 8Ks are also the same way. The 8Ks, make no mistake about it, the 8Ks are built up with the exact same structure as 4K in terms of how they handle the traffic and the packets. And in an 8K or a 4K, the forwarding of the control plane is completely separated from the forwarding part. So it's a data plane you need to be interested in if you're going to look at how am my router doing today with these commands, not the control plane so much. Okay. Those are, I think, fairly good tips for you to go home and look at how your routers are doing. You might be that I'm underselling myself because wait, I'm doing fine. I don't have to upgrade to a new router. Well, then why should you? Memory-wise, what about memory? Did you bring enough memory? That's a very common question when it comes to do I need to upgrade or don't I need to upgrade, and what will that give me? Will it give me more throughput if I upgrade memory? Sometimes it will, sometimes it won't. And we're going to look at why that is and where it doesn't give you any benefits. You can also run into the fact when your router is running so hot on DRAM that it will be unpredictable and might actually reboot at any time. How do you find out if you're close to it or not? That is not very clear either unless you know the commands for it. We're going to look at that part. First of all, we have two types of memory. We have control plane memory and data plane memory. The control plane memory is where iOS lives. iOS is living there, and this is doing all the iOS that holds the databases and it holds the commands. What iOS is doing, you see, it has the commands in it and the features, and you are configuring the router to do certain stuff. iOS will take those and give those commands to the data plane part. So it's called a feature invocation array that then will actually execute on the packets what you want the iOS to do with your configuration. That configuration sits, first of all, in iOS, and it also holds the databases, the route tables, all that good stuff. That as well as Linux. So the total memory you have in a 4K and an 8K, you have a memory bank, which is of a certain size. iOS works as a daemon. It works in a user mode on top of a Linux kernel. So you have a Linux that holds iOS, holds the forwarding plane, microcode, and all that good stuff, but it works as user daemons on top of Linux kernels. That means that we have to have memory enough to house the Linux as well. That also means that as you start using up more features and stuff and memory in iOS, Linux will have to assign resources to accommodate it. Which also means that the memory part from Linux will grow as your iOS is growing from that side. And at one point they will meet, and that will not be a good day for you when that happens. On the data plane side, those are more fixed. In the 4300, and those where we have a single silicon, we have a partition that is just tied to be just data plane, and it's fixed. You cannot upgrade it, that partition. On the 4400 series, we have a DIMM of our own, a 2 gig DIMM, that you cannot, don't try to upgrade it, it won't help. Because the microcode is written to only accept a certain amount, always have a fixed memory for data plane. But it doesn't matter, because in most cases, a data plane is it's predefined what it's supposed to be doing. You don't hold route tables, you don't hold VLAN tables, you don't hold those things in a data plane. You hold the packet instructions you're getting from iOS on that side. That's it. It's called a feature invocation array that holds that. And a feature invocation array basically is a loop. in which a packet comes in and it goes around that loop and gets bolted on to the features you have told it to do. So that part of the DRAM will grow as you have more advanced configurations. It will grow a little bit because you will have to hold more features in that feature invocation array where the packet moves around. You can change the data plane. So the data plane during packets for predefined control plane holding iOS for you, where you can grow iOS pretty much. And how much will iOS grow then? That's another question. When will it grow, and how much can you grow iOS on a router without it starting to go belly up or crash? And how do you look at it? Well, if you do the good old show memory, it will give you some numbers, but it won't give you the entire truth. And I wouldn't recommend you to use this as looking at the health of your router, because what it will do, it will show the partition assigned to iOS. There's two things to that. It's one which is for iOS itself, and there's one dynamic part that iOS can possibly use should it need to. And what you see in this example here is an 8 gig DRAM. You see roughly 4 gigs of total memory. Why is that? Because we're not looking at the Linux part, the memory where the Linux is. We only look from an iOS perspective here. When you do a show command, good old show command, you will always look at things from an iOS point of view. iOS is look at how much do I have to play with. 3.7 gigs. You can also read down here that 3.7 gig is my total playground of this memory. I'm using 312 megs of it only. I can, however, use 3 gigs of extra memory should I need to. And this memory, the 3 gigs, that you will be upgrading and extending when you buy a memory upgrade. And we're going to look at that in a while. That is very important for you to have, because iOS will grow from the 750 megs you have, and it will grow into that dynamic part until it gets to the end where the router starts acting very weirdly. So the more you can use, the better it is, of course, if you have high usage. Should you want to look at the data plane part you see here, that's, again, the magical command, platform hardware QFP. QFP remains from the ASR days, quantum flow processor. We have no quantum flow processor here, but we kept the code because we stole the code from the ASR guys. So we just didn't bother to change it. That one will show you how much total DRAM do I have for forwarding for data plane. This can be also something I will talk to you later. And how much am I using of that? 90 megs. This should, in normal cases, never, ever be exhausted. This is predefined, and it's taken, this case, a 256, a 4400 has 512. It should be enough. We have, however, seen cases with 4300 when they're really heavily used in certain unfortunate ways, where this memory is actually being exhausted. And when that happens, unless you change where you're using it for, forklift, you have to use another router. But the 4400s here, and we have only seen once or twice in the history of 4K, so you shouldn't be too worried. But it's good to monitor it. We have a milligram, which is how much buffer we have for packets, and that's called the memory platform information. That will show you how much buffer you have. Could be good to know as well. But those two are good to keep track of. But as I said, they don't show you the entire truth, what's happening in the router. It's showing how much is used now, but not showing you when will I risk this router really crashing, or when will it be dangerous for me. This is a good table for that. If you look at the left part, show platform resource will show you the entire box. This is a 4 gig router. The entire memory you have to play with. This is with Linux memory. 4 gigs. This is how much I have reserved, 4 gigs of memory. On the far right side, you see how much data plane memory I have on this box and how much I'm using. And you can see when we start loading up this DRAM, because one thing that will load up DRAM is databases in any kind. VLAN databases, MAC databases, route databases, in this case, RIPs, routing information tables. We start 100,000 at a time, and so if we start loading up more and more and the routing information base becomes bigger and bigger, you see the show memory, how it starts not using heap until in the beginning. It goes up to 750 megs. That's how much memory iOS can use without going to the dynamic memory. Now, as we start moving into more and more routes in it, you can see it starts chewing up memory on the heap memory as well, and that's all fine and good. But we also have something else we look at here. This is dangerous down here, and it may not look very dangerous on this. But the good thing here is we got one command that will show you the truth. And that is the one in the middle, platform software brief. That will show how much memory have I committed as a router. I've committed, first I'll start out with a pretty moderate way of 58% of memory, including Linux, because I said Linux grows, iOS grows, you don't want them to meet. At 100% they will meet. Roughly 100%. You can actually see a router doing 110% because at some point it says, oh, I met Linux here. I can't go any further, but I have to. So I don't want to crash just yet. So what iOS is trying to do is trying to take some of those services that are not immediately used and store them temporarily on the boot flash. And then you see 110, 115% sometimes. And this is really deep water when you're into that one. When you see this, and it's 91%, anything over 85, 80%, I would say, starts getting a little shady. It's getting into the 90s, it's really time to start changing, upgrading. All right? So that's important to know that. Do that. Committed memory is what you want to do. The XMEM will grow a little bit with configurations and so on, but not a whole lot, because this is not about handling packets. This is about holding a lot of data. That made this. And if you upgrade, remember that Linux takes half the memory. So this is what you get. And iOS will use the same amount of memory, but you will get so much more dynamic memory, heap memory, when you upgrade. If you're going to do a full internet routing table, you must at least be at 8 gigs. This also grows when you're doing SD-WAN. If you're doing SD-WAN, going from a normal traditional router to an SD-WAN router, you will also grow the amount of memory being used by both Linux and by the BibTel iOS. So you need 8 gigs for that. Otherwise, it will always be very, very close. You're up in those 91% if you do 4 gigs. I know we said we can do it, but don't do that. 8 gigs, it's recommended, and there's a reason for that. So, bottleneck, iOS memory, heap, can grow. It should not grow into the Linux part, because Linux will grow at the same rate. Beware of that. XMEM, will it be fixed in size? It could possibly, in some extreme cases, be exhausted. We have only seen a couple of times in the history of ISO 4Ks. If it does, you have to change the router to a bigger one. But you shouldn't do it, really. Okay, that's about memory. Next one. What do these guys have in common? Yes? End of sale. They have end of sale in common. Every single one of them will be gone come wintertime. They're all known platforms. So it's time now to start looking at a new brand CPE if you have these perhaps. If they will be, of course, be still there for 5 more years. But still, they will be end of sale. all those routers, just so you know. So it's time to start looking at the new, and how do you migrate from migrating from a 4K to an 8K router, an 82 or 8300. What's the best way to migrate? We also learned some of the architectural differences. Remember that 83 and 8200 are mainly just for the 4Ks. That's what we say. We built them to replace the 4Ks and to be a better version of the 4Ks. So let's stick to the 4Ks now when we start doing it. These are different platforms. We built them ground up to meet today's requirements. They have better ways of handling SD-WAN, because in SD-WAN everything is encrypted. These have a lot better encryption rate when everything is encrypted. We have a lot higher throughput on them. We have a lot better way of handling built-in security services on these routers. And that also comes with that we will have containerized services on for some of those services. In 4K, containerized services, and the big ones, were put on a control plane CPU on the side of the data plane CPU, which meant that if you put security services on a 4K, you might have to punt all the traffic through a path over the router to the control plane CPU for every single packet you do. That will tax performance crazily. This is not done here, right? And they're faster. And everything you put, they're made for anything you put on a containerized feature should be more efficient. And they come in 12, 8, and 4 core flavors. The lowest one have 4 cores, 8200. The highest one have 12 cores. They come as a router which is geared towards services, maximized for services. But should you not need all those services when you get the router, which many don't, you can give it a command and it will switch from a minivan that can do everything into a 2-seater sports car by just one command here. And it will switch into this. So you can still have services on the biggest one. The other one cannot have services anymore, but you can go really fast down the highway instead, without any trunk space. Do that when you get that router. You can switch that with one command and you will get that. Basically, it's the first router we have when you yourself can switch the way you want to have the cores on. Pretty cool, isn't it? The recommended path, I have some slides here on this one. Recommended path here into that, when you recommend it 4400 series, basically 2 rack units because it's more about modularity. The 8Ks run circles around 4Ks in performance. So that should not be an issue here. It's more about modularity. And the same goes for the smaller ones here. You bought 1 rack unit router, 8200 series, and you look at how much more throughput you get on these than the default bandwidth of a router. Remember that a 4K needs performance licenses or boost license even to get close to a 8K. You don't have anything like that on 8K. They will do this when they unpack the router, right out of the box. And are they more expensive? Well, I've heard that a lot. And we did an experiment. Me and William, we did an experiment here, and I did it on the 4K, on the 8K here. Will it really be more expensive? I took on my partner, customer, SC hat, whatever you want to call it, and just sat down and configured the router standard. Nothing else. No smoke and mirrors. No pink fluffy unicorns, nothing here. Just took its price list terms. If I want to do an SD-WAN, I want to do, for example, a DNA essential license with a T2 and SD-WAN, what do I need to put on a 44K to do that? What do I need to put on an 8300 to do that? Look at that. And every single one came out cheaper and with more throughput. And I didn't do anything here. This is just taking it off TCW. If I want you want SD-WAN, then what do I do? SD-WAN, so say I do traditional routing. Let's say I want 1 gig. I have a gig link. I want to use it all. I have 1 gig of IPsec. Yes, and I want to do 1 gig of routing. I don't know which one, but sometimes we'll have IPsec, sometimes we'll have routing. But I want to use it all. and I want to have 8 gigs of DRAM because I have a really big routing table in it. I didn't even go to a boost license. Mind you, 4451 with boost license itself is $6,000. I didn't even go to that. I went to a performance license with, added SAC to it, so I got the IPsec, and took an 8300 up there and added a T2 license to that one in DNA. And well, yeah, you see the difference, right? And in difference in throughput as well, at a lower price. Even the smallest one, I say I had a 1 gig link again. In Europe here, we all have 1 gig links, right? A link costs like a coffee in a Danish here, so why shouldn't we have a gig link? No encryption, just basic routing. IP base, nothing else. But I want to use my 1 gig link. So I want to have a boost license on the 4321. An 8200L will do 3.8 gigs out of the box. That is same as a 4451 with boost license. Bloody hell. And that they still came out cheaper. So no, they're not more expensive. There are, of course, cases where there will be because you have to go to a slightly bigger platform in some cases. Yes. But if you compare router for router, platform for platform, no, not really. They're not very most expensive. So, this shouldn't be. And also know that these guys are definitely not an SD-WAN platform. I just want to make that clear. We have seen that so many times where people think it's an SD-WAN platform. Yes, it can do SD-WAN. It will do SD-WAN better than the 4K because it's made for encryption better, but it's a traditional router. Guess what? It's using the same binary code as a 4K. Same features, exactly. If a 4K can do it, this can do it. Only exceptions are ISR-WAS, deprecated, so who cares? IWAN will not work on it completely. I'm not too sad about that, to be honest. But apart from that, good old router. Now, it does have DNA licensing and has a different license structure. So what does that do to you? How will you use that and what does it do? We took DNA license because we wanted to make it simpler. That was the whole point of it. We want to simpler across the product lines. We have IOS-XE on the switches. We have IOS-XE on the routers. IOS-XE on the wireless controllers. They have DNA licensing on that side. And it's working just fine. We want to simplify it so that a customer who have both switches and routers and wireless LAN control have an understanding of the same licensing structure. And make it simpler. You can transfer DNA licenses and switch it between devices without problem. We could not do it on 4K. All licenses are individual based. If you're going to RMA a router or you're going to change your router, you need a new license for it. We want to get away from that. Why don't we have one license that you can, if you want to switch router, park the license on a smart account, change the router to something else, put the license back on the new router and done with it. Pretty cool, isn't it, to be able to do that? And that's and simplified. Instead of having a plethora of port licenses, bandwidth licenses, boost and performance, and very granular feature packs, have fewer licenses, essentials and advantage. 2 things to choose from. Nothing else. So basically, it works like this. You take your router, you go and choose a router. You choose the feature packs that you would do on a 4400 series or G2 back in the days. You want to run SEC, do I run IPsec, do I run voice, do I run something else? And you figure out which one of those fit into my feature requirements. Essentials fit into many because it's got both the IP-based features and security features, and then some of from the higher features. Many times you're good with essentials. You only have those 2. Then each of those licenses, you will be getting a license from us for that router, and each of that license have 2 stacks. 1 DNA stack and 1 network stack that you will then have to your disposal in the smart account. What do you do with that? Well, those stacks are really two things. Well, the network stack is for traditional, normal, good old routing. That stack will be sitting on your router, consumed by the router itself, the hardware itself, because the router is not expected to have a controller. It's expected to be managed by you, CLI. And that's basically the exact same thing as a 4K feature pack, nothing different. It will sit on the router, consumed by the router, and it will be the network stack and the subscription that will then say, what can I run on the router? The DNA stack part will be there, and that's in case you want to use it's a controller-based environment. In SD-WAN, for example. In SD-WAN, the router is not in control of the feature. The vManage is. The controller is control of features. The controller is the one guiding and setting the features of the router. So the DNA stack license, the stack itself is not sitting on the router anymore. It's unlocked completely. It's sitting on the vManage part. And the DNA stack is now what will mandate what features you can put on this router through vManage, because it's a controller-based. Next difference, a network stack works just like an IP-based license on a 4K, as I said. It's perpetual. There's no renewal. It works just like it said. You put it once, you're done. No renewal on a network stack in normal routing. It works like a feature pack. DNA stack, however, is different. The DNA stack gives you entitlement to use a controller. And that controller is term-based. You're paying a 3 or 5 year license for how many, and you have to renew for that entitlement to have the controller controlling your router. After the 3 years up, you have to renew. The renewal is up, you forget to renew, the router will not explode. Or blue smoke will come out of it or stop working, but you are expected to renew. Otherwise, you're expected to remove the router from the network. We're not that mean that will make the router disappear or something. But they are term-based. So basically, you go in and you order it. You go in, you choose autonomous routing, for example, traditional routing. You choose your feature pack. And in one click, in the ordering tool, you choose feature pack, and on-prem for normal routing. You choose a bandwidth tier, and we're going to do that in 2 slides. Don't worry about it. And you choose the feature pack you want, Essentials or DNA, and you choose a term. Since it's perpetual, you do not choose anything else than 3 year. Unless you think of doing something else with the router within the near future, it's just switching it to our SD-WAN or something. If you have intention of letting this router sit in your network, not the normal router, you choose always the shortest term, because you never need to upgrade, you never need to renew. And that term is up, don't worry, the network stack won't complain. On the other side, you do the same thing on the SD-WAN side, but there you have to actually choose a term and you have to renew when that term is up. That's the difference. So what is the bandwidth tier? Well, the bandwidth tier is how much we expect the customer to pay for what they want. In an SD-WAN environment, we start from the top. An SD-WAN, everything that is transferring over the transport side, VPN 0, anything, we expect you to estimate that and get a license for it. Get the tier after how much you're running on the transport side, the VPN 0. In a non-SD-WAN environment, only IPsec, nothing else, not MACsec, not upper encryption like voice features and stuff like that. IPsec. We expect the ones running IPsec to estimate how much IPsec they're running and then choose a license that will comply to that or accommodate that bandwidth. If you're not running IPsec, you should always choose the lowest license, the tier 0, because we don't care about that traffic one bit. So for example, here is an example. And there's one thing you need to know, that when you're choosing a bandwidth tier, we always look at aggregate traffic, both in and out, right? the tiers in the licensing part is in nominal. That means one way. And there could be a really, really heavy math behind this, but we made it simple. You estimate how much of traffic that you need to buy a license for, how much you run in aggregate. Estimate that to your best ability, then then divide by 2 and choose a license for it. Simple as that. If you have an 83 and a running 11 gigs of traffic unencrypted, don't worry, take a T0, we don't care. If you're running 9 gigs of traffic, we also have you estimate 350 megs of IPsec, divide that by 2 and see where you fit in. Oh, fit right into a T1. Then some of the bigger routers, they start in T2 and T3. They're not on this subject here. But you might be running very, very high, then you might be wanting to go into those tiers. But you always take your estimated bandwidth or throughput, divide it by 2 before you choose the tier. And only IPsec, nothing else, okay? So how does it work in practice? Well, as I said, you choose in a normal routing, you choose that you will get both the network stack and the DNA stack in your smart account. You will have that tier you chosen, and you will have renewal in 3 years, but you don't have to worry about this. It will be consumed by the router. It will sit on the router, and when the term expires, nothing will happen to your router. DNA stack will give a complaint in the smart account, but nothing will happen to your router. Should you, at some point in time of this, want to change into an SD-WAN environment, you can do so at any time you want. What will happen is that the license will change, so that the DNA stack instead will now be taken out, the network stack taken off from the router, DNA stack will put onto the vManage, and you will have whatever term you had left when you made a change. You can do that self in a portal. Now you will change to an SD-WAN environment. You will be in a term-based mode, but now you've just changed the stack on the same routers. Done. And when that stack expires, you will have a nastygram say you need to renew your service. If you will be requested to or required to take the router off the network. They won't explode. Another cool part with the DNA license, oh, sorry, didn't I hear? Oh, missed that part. There's in the slide, there should be that slide as well, it's hidden here. Portability. You have a license for an 8200. You say I want to upgrade to an 8300 instead. You don't have to do anything. You take your 8300, 8200 you have, take the license you have on that, park it on the smart account, get the 8300 in, take the license back and slap it on the 8300, you're done. No worrying about different licensing, no worry about performance licensing, nothing. You have that license only to worry about. And it's fully, you can take a 4K with a DNA license and slap it onto an 8300. You cannot do the other way around though, but you can do that. And between the 8Ks, and you can always just transfer them as much as you want. So license is actually pretty good once you get into it, and it's not very, very complicated at all. And no, you will not be stuck in subscription in a normal routing environment. So that's something to think about. Want to debunk that. And you should be good. If it works on a 4K, it will work on an 8K. You cannot tell the difference. One router cannot tell the difference from the other when they work together. It's easy just to slap a few 8Ks in your network, have them work together, no problem. A 4K cannot tell the difference if you're talking to an 8K or not. Yes?
What happens if your traffic exceeds the tier? So you've got 400 meg tier, and you've got 450.
Okay, what happens if my traffic exceeds the tiers? Today, in a regular routing, nothing happens. Nothing will stop. The bandwidth licenses you have chosen will not impact the performance of your router one bit. Not one bit. They can't do it. So router is one thing, the license you choose another thing. That's a gentleman's agreement. If you choose to put up a higher tier on your router than you have bought, then the smart account, in some cases, will complain and say, hey, I have a discrepancy here. You have one license here and you have one bandwidth here on my side. But it won't stop your traffic. No, It's a gentleman's agreement. Okay. So, know your performance. Know your own business. And never take any performance data face value without knowing what goes into it. That is super important. And know the workload of your own platform before you do the change. That means that if you know the workload, whatever you change into will be more right on spot, right on the money for what you want it to be. If you know that, will save you a lot of money. And there are no learning curve. These works perfectly the same. And I can say you honestly, I worked with these guys. I've been a product manager for these guys when they came on. And since 2020, I have not known a single cap case that relates to the platform viability. They are solid platforms. So it should be fine. There's no learning curve. If the 4K works, you know how to handle that. You know how to handle 8K. And DNA licensing is actually not that complicated, and it will not get you stuck in subscription. I'm repeating it once more. Okay? And that's it. Thank you so much for listening. And do fill in the feedback here and the survey. Bear in mind, though, that survey is in American scores. So 5 is okay, and 4 is eh. Okay. Thank you so much.